I'm Anil Kumar, and in this video we are going to explore operations with functions. Given a of x equals to x and b of x equals to 1 over x, where x is greater than 0, find the graph of the function f of x equals to a of x plus b of x, where x is greater than 0. So we are given two functions, a linear function a of x and reciprocal function b of x. We need to find the graph of combination of these two functions, f of x. Let's see how to do it. Let's first sketch the function a of x equals to x, and for both these functions we are considering domain of x greater than 0. So a of x equals to x means that's a straight line, right? So and it is greater than 0, so we have a hole here, but all these points lie on the function. Connecting these points, we get the function. So that is a of x for us, which is equal to x. Now let us sketch b of x, which is reciprocal function. So at x equals to 1, 1 over 1 is 1. Now at x equals to 2, the value will be half. At 3, it will be 1/3, then 1/4. So it is approaching 0 as we go on this side. So I can always connect these points and get my graph of 1 over x to the right of 1. As the numbers of the value of x is less than 1, let us say x is half. In that case, b of x will be 2. If x is 1/3, it will be 3. 1/4, it will be 4. So it is approaching the y-axis. Y-axis, in fact, is the vertical asymptote for the reciprocal function, right? So that is our function b of x as equals to 1 over x, correct? I haven't gone into details of sketching these functions, as you know that by this stage. Okay, now what do we need? We need to sketch f of x, which is combination of these two. That means f of x is x plus 1 over x. That is the combination of a of x and b of x. So let's combine these two functions and then get f of x. We'll start with the point 1. So when x equals to 1, a of x is 1, b of x is also 1. 1 plus 1 is 2. So we get this point, correct? If x is 2, a of x is 2, and b of x is half. Adding 1 and half, you get 2 and a half, so we get a point there. For x equals to 3, a of x is 3, b of x is 1 over 3, so it's 1/3, more than 3. For 4, it is 1/4 more than 4, 1/5 more than 5. That means what we see is that as x approaches infinity, the function f of x approaches x. Do you see that? So on this side, I can always draw a graph which is kind of approaching the linear function. On the left of x equals to 1, if my value is half, in that case it is half plus 2. So it's 2.5, right? So it is 2.5. We get a point here. If it is 1/3, then 1/3 for x and 3 for y. So we get 1/3 more than 3, right? So likewise, what we observe is as the x value approaches 0, f of x approaches 1 over x, right? So we have a function which is kind of like this. So it is approaching 1 over x, correct? So that is our f of x. I hope the steps are absolutely clear. Now let us analyze the equation and then check our result. You can see from here that if x is approaching infinity, then 1 over x approaches 0, right? And therefore f of x approaches x. So that is what we see here, correct? As x approaches 0, 1 over x approaches infinity, a very large value, and therefore f of x approaches 1 over x, and that is what we are trying to see here. You see that? But at x equals to 1, it is at 2, which is its minimum value, right? So let us see how we have sketched this function. To start with, we know f of x is combination of a of x and b of x, that is linear function and reciprocal function. We observed that as x approaches a large value, 1 over x approaches very small value, and the function approaches x. That is this part. But as x approaches small value, that is less than 1 and approaching 0, the function approaches the value of reciprocal function. And f of x has a minimum at x equals to 1. So with the help of combination of functions, we can actually get to know new functions, and that is what we are going to learn in these set of videos. I hope you appreciate it. Thank you and all the best.